Good morning, everyone. Um, so now we are going to discuss about an algorithm which is known as Fleury's algorithm to find an Euler path or an Euler circuit in a given graph. So the steps in this algorithm is like this. First step, we make sure that the graph has either 0 or 2 odd vertices. If the graph has 0 odd vertices, then we can go for an Euler circuit in the graph. And if it has 0 odd vertices, exactly 2 odd vertices, then we can have an Euler path in the graph. So if there are 0 odd vertices, then we can start from any arbitrary vertex of the graph. And if there are exactly 2 odd vertices, then uh, we can start from any one of that odd vertices. And if there are more than 2 odd vertices, or if there is three or four or five odd vertices, then the graph cannot be an Euler graph, because we have a theorem, an Euler graph, in an Euler graph, degree of every vertex is even. Euler graph is a graph which contains an Euler circuit. So that's the preliminary check. And now in step 3, we follow edges one at a time. And if you have a choice between a bridge and a non-bridge, we always choose the non-bridge edge. And we stop when all the edges have been chosen. So we illustrate the concept using a simple example. Here we have graph with vertices A, B, C, D, and E. And degree of A is equal to 2, C is 2, D is 2, and degree of E is also 2, and degree of the vertex B is 1, 2, 3, 4. It is 4. So degree of all vertices are even, and therefore the graph is an Euler graph. Now, to plot or to use the algorithm, we first consider the vertices, and we start from any random vertex. Say we start from the vertex A, and we can choose any edge from A. So I just choose the edge from A to E. Let's choose randomly. That's our first edge. Then from E, there's only one edge, that is E, from E to B. So I choose that edge from E to B. Then from B, we have 3 edges available, from B to A, from B to C, B to D. So out of these 3 edges, if you choose the edge from B to A, that edge is a bridge, actually bridge of the remaining vertices of the graph. So what happens here, if we already choose the edges from A to E and E to B, then the remaining graph, in this remaining graph, the edge from B to A is a bridge, and the edges from B to C and B to D are not. So in such a situation, we have to choose the edges which are not a bridge of the remaining graph. So we choose either the edge from B to C or from B to D. So I just choose the one from B to D. That is our third edge, B to D. Then from D, there is only one choice, that is D to C. Now then C2B. So in these stages, we don't have any other options. And from B, we choose the edge from B to A. So we end up at the starting vertex and we run out of edges. All the edges are being used exactly once, and that's our Euler circuit. So the Euler circuit in this graph is A, E, B, D, C, B, A. This is an Euler circuit in this particular graph. And remember one thing, in many stages we have an option to choose between edges randomly. So from at the vertex B, when we first meet the vertex B, we have two options. So, and we make the selection randomly. So the Euler, we can have different Euler circuit in the same graph. Anyway, the Euler circuit contains all the edges of the graph exactly once. So this is a simple method, and the only thing, whenever we move forward, make sure that we don't use any bridges uh, unless there is no other choice. If there is a non-bridge edge, then choose that non-bridge edge first, and then after we use all the non-bridge edges, then we can use the edges which are bridges of the remaining graph. Okay, that is it. Flores algorithm.